Greetings everybody, this is slicedlime and welcome back to the third and final part of our Predator Explained Behind the Scenes series. The first part we went through the clock layout and the scoreboards, and the second part we went through the entire calculations for how we produce average colors for each piece of the armor. And that means that today all that remains is to explain how we turn that information into a piece of leather armor on your body. So, the problem is now we have three values. We have a Predator chest red, green and blue, and we wanted to pretty much, that lets us calculate a color value for the leather chest piece. The thing with that is we can't just calculate that value and then throw it into a /give command. There's no way to do that in Minecraft. So what we need to do, what we end up doing, is this kind of stuff over here, where if your score for the Predator Leggings red scoreboard is 30, and your score in the Predator Leggings green scoreboard is 1, and your score in the Predator Leggings blue scoreboard is 7, then we're going to do a replace item on your legs armor slot with leather leggings, and they're going to be called Predator Leggings and they have this color value. It's pre-calculated. That gives us all of these blocks, and since we have 32 possible values in red and 32 possible values in green and 32 possible values of blue, that gives us 32 times 32 times 32 possible blocks. That's 32,768 blocks. And then of course there's 4 armor slots, so that gives us 131,072 command blocks, which is all of these ones from here on out. That's all of these. Now the problem with the situation we're in right now is that if we just want to run all of those commands, then we have to run all of these every tick, which it will lag you to pieces. It would not be able to be in this world. So we have to fix that somehow. And the way we fix that is by staging it up a bit, and that adds a bunch of overhead to the amount of command blocks we're running, but it helps performance because we don't run all of those every tick. So what we do is things like this. We execute for every player who has a red score of 0. And if you have a red score of 0, we're going to fill a certain row of redstone blocks. And that is going to be something like this row. And this is laid out so that this actually here starts in the middle of the chunk. It starts at the 8th block in the chunk, which means that we can fill 16 blocks this way. So we fill an entire chunk's worth of blocks, but half of them is going to be in one chunk and half of them is going to be in another chunk. So we don't exceed the clocking blocks threshold. And these are going to look a bit similar. So if you have a score of 18, so this row would only be filled if we had a score of 18 in the red scoreboard for the Predator helmet. But we still test for it again, because if you're running this in multiplayer, then we don't want to run this for all players. We want to run it for only the player who had the score of 18. And then we test if you have the green score of 0, then in that case we're going to fill another row of redstone blocks, and that's going to be over here, one of these. The problem is here we need for each of these 32 numbers, then we need 32 command blocks, but we actually need 32 more because we want to set first stone and then redstone. So that gives us 64 command blocks to run for each one of those, and since we can have 4 around each redstone block, that means a line of 16 redstone blocks, which would normally take us over the 63 clocking blocks limit. But laying them out in exactly this manner means that we rarely fill more than 5 times 8, so 40 command blocks in each chunk. And then we've gone through the entire cycle. You end up over here with a command that essentially is test for all 3 components and a replace item. And then the whole thing is pipeline, as I mentioned. So if you look closely at this first tick row, then we're actually going to be doing the calculation for the Predator chest, and then we're going to be doing the color detection for the Predator boots, and then we're going to be doing the item giving for the Predator legs. So that's why these are different. And there are different amounts of command blocks on each one of them. And the process for all of that is we start by detecting the blocks around you, if they are blocked or not, to figure out which of the blocks we should be looking at. Then we detect the colors of the blocks around you and store them all into one big number in one scoreboard. And then we do a bunch of fancy binary number related math to separate the components from each other. And then we run a whole ton of logic, which ends up triggering one of these rows, which ends up giving you one specific leather armor item. And that, my friends, is the process of Predator boots, legs, chest, and helmet. And at the same time, of course, an explanation to why there was a need for so terribly many command blocks. So as you can see, the detection blocks down here aren't all that many. Those are the ones that we see at the very bottom of the world here. The ones laid out in 3 rows here. There's quite a lot of them. If you look, they go all the way over there. But they're nothing compared to all of these. So the way to make this whole thing smaller is to reduce the amount of bits in your color values. So if you went with 16 bits instead of 32, then you would get 16 times 16 times 16, which is 4096 times 4 for difference. So that would be 16,384 command blocks instead of these 132,000 or whatever they were. So that would reduce the amount quite significantly, but also would reduce the quality of the armor. It would match the colors more poorly. But nevertheless, that is a modification that I intend to try. I tried it before a long time ago and I wasn't satisfied with the results, but I'm going to try it again to see if I can get this whole thing to be a bit more multiplayer friendly. So I hope some of that made some form of sense to you, and I'm gonna just leave it at that. Thank you very much for watching. My name is slicedlime, and I will see you in the next video. Bye bye.